Hello dear students, today I will start third unit, that is random variables. You know about probability, statistics, mean, median, variance, standard deviation, etc. Here in the syllabus there are random variables. Okay, so the random variables as mathematics we know what variable takes values, can take values in the sense real case, then can take any real value either within some interval or within a range. Okay, so the random variable, here random variable, how can you define? For cases just like suppose in case of probability, just we make sample space. Okay, so random variable is a real valued function. Variable means takes some values. Okay, so take real values. So we can suppose denoted by x, then random variable the x is a real valued function. In the mathematical sense, we can define this as a real valued function whose domain is sample space for an experiment. Okay, so real valued function means this is a function from, because we know function domain to codomain, domain to range. Real valued function means what? F, domain to set of real number. Real valued function, value function is real here. Similarly, random variable, as a mathematical sense, we can define random variable is a function, real valued function defined from sample space to set of real number, real valued function whose domain is sample space. Sample space related to an experiment or random experiment or random experiment. Random experiment means its outcomes depends on chance. Okay, equally likely outcome may occur. Okay, so x is a real valued function whose domain is sample space for an experiment. Random experiment means its outcomes depends on chance. So here x, just like fx, where x is belongs to what? Domain. Domain. Here as sample space. Now suppose, for example, a fair die is thrown, then we can get on the top face number 1, 2, 3, 4, 5, 6. So for that experiment, on first trial, we get sample space 1, 2, 3, 4, 5, 6. So this is domain for this random variable. We can define a random variable. We can define a random variable which can take these values. Can take value 1, can take value 2, can take value 3, 4, 5, 6. Getting number on top face of die for experiment. Can get 1 or 2 or 3 or 4 or 5 or 6. These are the points of sample space. So x is random variable defined on this sample space as a real valued function. Okay, x can take these values. Here sample space, getting 1 depend on chance, getting 2 depend on chance, getting 3 depend on chance. So x can take values real valued 1, 2, 3, 4, 5, 6, and getting this value, taking this value by x depends on chance. So random variable, for to be a random variable, there are properties. Random variable takes values which depends on chance, or it takes values just like discrete values here 1 or 2 or 3 or 4 or 5. So this type of example can be given for random variable. Suppose we throw 2 dice at a time and we denote x, sum of numbers getting on top of 2 dice. So x can take values what? Random variable can take values what? 1 and 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This value can take random variable. 2 taking value 2 depend on the chance on first die on top 1, on second die 1, equals to sum of numbers getting on top faces of 2 die, throwing 2 die. On chance, if first show 1 and second show also 1, then we can get 2. 3 for this outcome will be what? First show 1 and second show 2, or first show 2 and second show 1. 4 first show 2 and second show also 2, then 4 can get this. 5 2 3 3 2 4 1 1 4. These are the possible outcomes, but random variable takes value because random variable is defined as sum of numbers getting on 2 faces of die. So if this, then also sum 5, this also sum 5. First show these 2 and second show 3, first show 3 and second show 2, first show 4, second show 1, and also by this, in this 4 outcomes, random variable takes value 5. Okay, so these are the possible outcomes which are in sample space, but these are the values can take random variable by throwing 2 dice and defining x as a random variable, getting sum of 2 numbers showing on top face of die, can get like this. This can get 6, 6, 5, 6, 6, 5. Okay, and 5, 5, 10. There are the outcomes. And these values of random variable depends on chance. Well, maybe 2, 3, 3, 2, 1, 4, 1, 1, 4. These are equally likely. Maybe any event occurred. So, random variable is a real valued function defined on the sample space as a domain. Okay, and random variable having two properties. Random variable can take values just like discrete values. What? Just like this 1, 2, 3, 4, 5, 6, 7, 8, 9. Discrete values means 2, then 3, not in between 2.5, 3, 2.6, 2.7, not continuous. So discrete value, just a natural number. Okay, and taking these values depend on chance. So this type of a function is called random variable, and sample space related to experiment and random experiment. Random experiment means outcome of experiment are depends on chance. Okay, so random variable can take values. Okay, so here we can suppose this random variable x takes values x1, x2, x3, x4 and so on up to xn and when x equals to x1, when random variable takes x1, then probability of this means just consider throwing a die. The random variable can take 1, 2, 3, 4, 5, 6. So now probability of x equals to 1, probability of taking x equals random variable takes value 1. Okay, and 1 means showing 1 on top face. Showing 1 on top face by a die, probability 1 by 6. Similarly showing 2, 1 by 6, 3, 1 by 6, 4, 1 by 6. Clear? So, this is equals to what? 1 by 6. Similarly, x equal to 1, 2, 3, 4, 5, 6 again. Probability of random variable. When random variable takes value? 1. This is 1 by 6. For throwing, suppose 2 die throwing. Then possible outcomes are what? 6, 6, 36. There will be 36 points in sample space. Okay? Now, when at that case 2, 3, 4, 5, 6, 7 up to 12. Suppose random variable takes 2. Sum of two numbers are 2. Corresponding to this, sample points are what? First showing 1, second showing also 1. So 1. So 1 by 36. Total case is 36 and favorable case for this 1. And Px equals to 3 means sum of two numbers getting on top faces. What? X equals to 3 means first may show 1, second show 2. First show 2, second show 1. That is there are how many possibility? 2. So 2 by 36 means what? 1 by 18. So this is equals to what? 1 by 18. And these are the probabilities. These are the probabilities corresponding to the number 2, 3, 4, 5, 6, 7 up to 12. So if we list all the probabilities corresponding to this, suppose Px equals to x1 denoted by P1. Clear? Then P1, its probability P2, its probability P3, its probability P4, and so on, its probability Pn. Okay, that is probability of random variable. Clear? So you can also write like this. Then this type of listing values of random variables and corresponding probabilities are called probability distribution. Are called probability distribution of random variable x. Clear? These are the possible values of random variable. Corresponding probabilities are these. So this is probability distribution. Called probability. This level listing is called probability distribution of random variable x. Okay. Now here, random variable takes discrete values, then called discrete random variable. Now we can see that maybe when we consider just like heights, weights, temperature, etc., then we know height or temperature or weights, this type of quantity can take values continuously in an interval. When random variable takes continuous value in an interval, then called continuous random variable. Clear? Continuous random variable. Just like this, when random variable is not discrete variable, it is called continuous variable because random variable can take values continuously in an interval. That in that case we say that random variable is continuous random variable. Generally, just like this, we can suppose probability equal to x equals to a. Now, if we write like this, x is less than a. That this so what? Continuous value less than a. Continuous value up to. If we write like this, p x less than a to b. That means there are interval a to b, two numbers, suppose 2, 3. Then random variable, the values of random variable can take values any value between 2 and 3. Continuous random variable. So when random variable is not discrete, then we can consider continuous random variable. Okay. Now probability density function. So here we see that probability function means x, values of x, px, probabilities of x. Now probability density function. Probability density function probability density function. It is used in case continuous random variable. Okay, because discrete random variable, in case of discrete random variable, here they are given x discrete values 1, 2, 3 and corresponding probabilities are we are writing. And for probability density function, just here we write like this: probabilities corresponding to all discrete values of random variable. Discrete probability distribution, called discrete probability distribution, when we write probabilities corresponding to discrete values of a random variable, discrete probability distribution we can get. Here probability density function is used for continuous random variable. Continuous random variable. Suppose x is, if x is a continuous random variable, then continuous random variable. We know discrete, in case of discrete, we can write probabilities of discrete corresponding to discrete values of random variable. Here, if x is a continuous random variable which lies between in an interval, then for probability we use probability density function, PDF. Clear? So here, if x is a continuous random variable, then probability of x can be expressed, because x lies in an interval. So then probability of x which fall means in an infinite small interval, infinite interval, because every interval, if mid value is x, suppose for example if 2, then 2 minus half and 2 plus half, this is an interval 1.5 to 2.5, this is an interval. Midpoint is what? Midpoint is 2. Midpoint is 2. This is an interval. So in this interval, so we can make an interval taking mid value x, just like this: x minus half dx and x plus half dx. We can make an interval just like this, which fall means, suppose probability of random variable, this random variable fall in this interval. Random variable can take values in this interval. That is, we can write also like this: x minus half dx is less than x is less than this. Clear? X lies between this and this, just like this. X lies between a and b. A, b. This is a and this is b. Here interval is taking midpoint as small x. Midpoint as small x. Okay. So if x is continuous random variable, the probability of x which fall in means random variable fall, the value taken by random variable fall in this interval can be expressed. What we express? Probability of this can be. Probability of these which fall in this interval can be expressed as fx dx is expressed be expressed as fx dx such that we can write probability of this is equals to fx dx. Probability of random variable which lies between x minus half dx, x plus half dx. Clear? Here we can write just first comma interval. Okay, this. So this is new thing. Fx dx is this. This fx is new thing. This fx probability fx dx. Here fx for continuous random variable. Small x is what? X can take value x. Capital S can take value small x. Okay, so here this fx where fx is a continuous function. Continuous function. It is a continuous function of x. Of x means capital X means a small x. Because x takes values small x 1, 2, 3, 4, 5, 6, n. So fx, this is a continuous function. This is a continuous function of x and satisfying which satisfies two conditions. That is the main condition for PDF. It is called fx. This is called PDF, probability density function. It satisfies two properties. First is fx is greater than equal 0. Fx is greater than equal 0. Second, integration of, because it takes values in an interval. So a to b fx dx equals to 1. Where x lies between a to b. Clear? X, capital X. You can write capital X. We can also write minus infinity to infinity fx dx equals to 1, where minus infinity less than equal x less than equal infinity. We are not less than equal like this. We can write this or also can write this, because if this is line, this is minus infinity, this is plus infinity, and this is a and this is b, then we can suppose here fx equal to 0, here fx equal to 0. So in place of this we can also write this. Our actual calculation will be find from here when x lies between a to b. So this fx satisfies two conditions. Fx is greater than equal 0 for all x belongs to a, this or this greater than equal 0. Second condition, a to b fx dx equals to 1. Then this function is called probability density function. Here x is continuous random variable, and this random variable takes values in an interval. Suppose this is interval then probability of this random variable can be expressed as like this, fx dx. That is, p this is equals to this. Here fx is called probability density function, which satisfies two conditions. Fx is greater than equal to 0, this is equal to 0. That is property of probability density function, this and this. This or this we can write. Clear? So by using this definition, we will solve some questions. Clear? Here, for discrete, in place of integration, we use summation. Just like this. Here, in discrete case, x1, x2, these are the discrete values of random variable, and probability, it can be also denoted like this, pxi, 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 that is p1, p2 and up to pn. These are the probabilities, discrete random variable, discrete probability distribution. So here, this probability function also satisfies the condition. In place of integration, we use summation. So I equals to 1 to n, pxi equals to 1, where I equals to 1 to n, these are the values. Sum of probability is equals to 1, and also probability is greater than equal 0. For discrete random variable, for discrete probability distribution, sum of probability is equals to 1, and probabilities are non-negative, that is positive. Same here for continuous probability distribution. Here we use probability, here probability function, probability is here probability density function, that is denoted by fx, and it also satisfies this type of condition. In place of summation, we use integral sign. What we use? This is for discrete. This is for discrete. This is for, and for continuous. For continuous, what? In place of this, interval. X 1 to n, discrete values. Here x lies between interval a to b. So a to b, fx dx equals to what? 1, first condition. And fx greater than equal 0 for all x belongs to ab for this interval. Because x lies with values in this interval, Here x are discrete values. So all pi's are positive. Here also this is positive for the all values of this. So here summation here, this is for discrete, this is for continuous. So remember it. Okay, this is the condition. By using this condition, we have to solve some questions. Clear? So total probability is 1. Here also that same for continuous random variable. Okay. When we write like this, fx and interval like this, we can say this is continuous probability distribution. Probability distribution of a continuous random variable is known as continuous probability distribution, and corresponding to discrete random variable called discrete probability distribution. Okay, so by using this definition, here probability function, probability density function, random variable, etc. So we will solve some questions. So take a question in which the probability density function of a random variable x, the probability density function of a random variable x is given by, we can write probability density function as fx or px, denoting by like this. We can denote also by px or fx as you consider. Okay, here for discrete that is probability function, for continuous that is probability function. So in these questions, probability density function or probability function of a variate is given like this. Px equals to what? Otherwise 0, 1, 2, otherwise. This is given. Given PDF. Clear in this question. Okay, and we have to find what? We have to find first is value of k. Value of k. Second, p x less than 2 and p and third, distribution function. Okay, so this is our given form in question, and we have to find like this. Here we see that by definition PDF, it is for discrete random variable. It is for discrete random variable because for x equals to 0, for a particular value is k. For x equal to 1, 2k. For x equal to 2, 3k. Otherwise 0. Otherwise all values are 0. That means here how many values can be there? Less than 0, greater than 0. So less than 0 means any discrete value. Also there are discrete values less than, but that for that part value of the px is 0, and for greater also 0. So we have to find this. This is the PDF for a random variable. They are discrete. It is very clear. Okay. So solution or target is finding value of k. Clear? So this is PDF. According to PDF, we know what? By property of PDF, we know that property of PDF, we know that what? First property what? Px is greater than equal 0. Px is greater than equal 0, and second, what? Two property are there. Sum of Px is equals to 1. Because here discrete random variable. So by property of PDF, probability density function, we know that probability is greater than or equal to 0, and here summation Px is equals to 1. Clear? So Ps is greater than or equal to 0. All values are greater than or equal to 0. Means maybe 0 or greater than. That is, K will be positive value. Clear? So first of all, we have to find the value of K, positive value. Second condition, sum of probability is equals to 1. Clear? So here, how many probabilities are there? How many probabilities are there? 1, 2, 3, 4. So sum of Px is equals to 1 means probability functions are given like this. This is probability, this probability, this probability, this probability for all values of x. So here k plus 2k plus 3k plus 0 equals to 1. Now we can solve it. 2, 3, 5, 6, 6k equals to 1. So k equals to what? 1 by 6. So this is the value of k. Clear? This is the value of k. Now k equals to 1 by 6. So value of k is k equal to 1 by 6, which is also greater than 0. We can see. This is the value of k. Now questions second. Okay, here by definition it is clear that for discrete random variable. Okay, now this is the value of k. First question, solve. Okay, first is this. Now second we have to find the value x less than 2, x is less than or equal to value of probability. Clear? Here x is less than 2, just here discretely defined. That means for x is equal 0, this, x equal 1, this, x equal to this, otherwise this. That means for x less than 0, we can suppose 0 value. Because finite interval can be made in finite interval, except that finite interval, in other places we can suppose probability 0. So here x less than 0, for x less than 0, 0. Here 0, otherwise means x greater than 2, 0. Clear? Now, second, here we get k equals to 1 by 6. So, since k equals to 1 by 6, therefore, we can write PDF as Px equals to 1 by 6 if x equals to 0, and 2 by 6 k equal to 1 by 6, put k equal to 1 by 6, then k 2 into k equal to 1 by 6 means 1 by 3, 2 by 6, 1 by 3. If x equals to 1, one by 6, here 2 by 6 means 1 by 3, and 3 by 6 means 1 by 2 if x equals to 2 and otherwise 0. We can write like this. Now using this we have to find like this. P x less than 2. Now probability of random variable x less than 2. That means what? Probability of x equals to 0. Define at 0. Clear? Or x equals to 1. Both may be. Clear? Both may be. Because less than 2 means 0, 1, 0, 1. So 1 by 6 plus 1 by 3. This can be written as or. Probability of this or this means plus sign. So probability of x equals to 0 plus probability of x equals to 1. So this is equals to what? 1 by 6 plus x equal to 1 by 3. So this is equals to what? 3 by 6 equals to 1 by 2. So this is Px less than 2. So Px less than 2 equals to 1 by 2. Clear? Now 1 by 1 we can get the value. Second value Px less than equal to. Px less than equal to. This equals to what? P less than equals to. So P equals to 0 or x equals to 0, 1 or x equals to 2 also may be because less than equal to. So this is equals to what? Or maybe this, maybe this, maybe this or this or this. So Px equals to 0 plus Px equals to 1 plus Px equals to 2. So we can get Px equal to 0 means 1 by 6 plus 1 by 3 plus 1 by 2. Clear? So what? This is equals to 1 by 2 plus 1 by 2 equals to 1. So this is value 1. Clear? 1. 1. And also value P and also probability of 0 less than x less than 2 is equals to x lies between 0 and 2. 0 and 2. Not 0, not 2. Only one value 1. So Px equals to 1. This is equals to what? 1 by 3. So this is the values of this, this and this. Clear? So by this process, for discrete random variable you can get the probabilities. Clear? This is the PDF. Okay. Now distribution function we have to find also. Distribution function of x. Distribution function of x. So first of all I will discuss about distribution function. Okay. So here just this definition is also required. So we can write after putting the value what? Here 1 by 6 PDF is what? 1 by 6, 1 by 3, 1 by 2, just like this we are getting. Okay, just write for using. Okay, we have to find what? distribution function. Now, first of all, we have to discuss our distribution function. Clear? So here we know that probability density function, probability density function, probability here distribution function of the random variable. Distribution function means generally called cumulative. Cumulative distribution function or distribution function. Distribution function of random variable x. Of random variable x. Clear? Cumulative distribution function or only distribution function, you can say. Distribution function of the random variable. Clear? That is denoted by fx. Denoted by fx. Distribution function for the random variable. A small x means what? Value of random variable x. So if x, the probability of random variable x which is less than or equal small x, that is there is particular value, suppose its values are given. For a particular value, if we take, then the value of x less than equal that particular value. This is defined like fx. For discrete, it can be written like this. Sum of pxi x is less than equal xi. Clear? For example, suppose x1, x2, x3, x4, x5. Then x is less than equal x3. Px 3 means here not only px3, here I. So this means x I equals to 3. Then we have to write what? For x equals to, if lower value 1, then probability px1 plus probability px2 plus probability px3, this will be the value. If I take 3, clear? If 2, then up to 2, then 5, then up to 5. So this fx, cumulative distribution function of random variable x is defined as the probability of random variable when random variable is less than or equal x. In discrete case, we can write fx is denoted by distribution function of x, and fx equals to px is less than equal x. Is this equal to this? This is the formula. Okay, just remember it. Clear? For discrete case. Clear? For discrete random variable x or discrete random variable. For continuous variable x or continuous random variable fx equals to clear? This, because there is some continuous random variable, in place of summation we use integration minus infinity to x. Why minus infinity to x? Because minus infinity to x means less than equal x. That is, suppose continuously here is x, then last value minus infinity. So if the interval is this, in this part PDF is given. For this part we can suppose PDF is 0. Then we can also combine this to minus infinity to x. Can get value minus infinity to this and this to this. Here 0. So we main value is there for this. So this. So fx equals to this for continuous random variable. This is the distribution function. Its properties. Okay. So here main thing is note down its properties. First of all, what from here? This is for discrete. This is for discrete. Okay, this is for continuous. Now for this question, we require this formula. Clear? We have to find distribution function of random variable x. Now here there are some properties for this distribution function for continuous random variable. I will discuss later. Okay. Now for these questions we require this definition. Probability distribution function for discrete random variable. Okay. So now for solving these questions, for finding and distribution function, we use this formula. Okay. So note down this definition for distribution function. Here for third, we know that distribution function of a random of a discrete random variable x is given by what? Fx equals to px less than equal x, sum of x is less than equal to xi, p xi. Therefore fx equals to 0 if x less than 0. We will consider for all values. Here x equals to 0 for this, and below value less than x, nothing is there. So this can be 0. Put now fx equals to what? Step by step. This is 0, this is 1, this is 2. So here sum of x less than equal 0 px. Okay. Then less than equal 0, less than 0, at equal 0. So less than 0 for 0 and at equal 0, 1 by 6 equals to 1 by 6 if x equals to 0. Here x equals to 0. Clear? Also x is less than equal 1 px, step by step. Here like this 0, 1, 2, otherwise all apart and less than part. So step 1, this part, this part, this part, this part and this part. There are how many parts? 5. So this is equals to what? Less than 0, part means 0, plus add 0 means 1 by 6, plus add 1 means 1 by 3. What? 1 by 2. 1 by 2. If x equals to 1. Clear? And again, fx equals to what? Capital X less than equals to, step by step, less than 0, 0, 1, 2 and otherwise greater than 2. This px we can get what? For 0, for less than 0, for 0, for 1, for 1, 1 by 3, for 2. This is equals to what? 1. If x equals to 2. Okay. And one part is this otherwise part. Otherwise part means what? X is greater than 2. X is greater than 2. Also, we can write here also fx is equals to 1 if x is greater than 2. Why? X is greater than 2 means total means lower value up to upper value. Sum of probability is what? 1. Similarly, for continuous distribution, minus infinity to x minus infinity to upper value plus infinity fs dx equals to always 1. And here we see that after the case x equal to 2, for all values means for upper up to upper part, from lower part to upper part up to x greater than 2, 1 total probability. Clear? So finally distribution function is given fx equals to this, 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 this. We can write it like this. Distribution function means what? Value of capital Fx. Capital Fx. Thus we can write thus we get distribution function as fx equals to zero if x less than 0, 1 by 6 if x equal to 0, 1 by 2 if x equal to 1, 1 by 1 if x is greater than, because is greater than 2, 1 equal to 1. So mixing x is greater than equal to 1. So 0, 1 by 6, 1 by 2, 1. Okay. 0, 1 by 6, 1 by 2, 1. So this is final distribution function. Fs equal to this for this, this for this for this, and this for this, for total values. This for discrete distribution, discrete random variable. Okay. Clear? So by using properties of probability density function, we can get distribution function also and PDF completely by finding value of constants by using total probability 1 and probabilities are greater than equal 0. Okay. Take another question. Here, a die is tossed thrice. A die is tossed thrice and a success is getting 1 or 6. Find the mean and variance of the number of success. Okay. A die is tossed thrice, 3 times. Okay, 1 time, 2 times, 3 times means first, second, third. And we have to find mean and variance of number of success. So we have to define random variable as number of success. So what values can take random variable here? Very simple. Random variable, because 1 time throwing, another time throwing, another time 3 times success. Maybe no success, that is out of 3 tossing we will not get 1 or 6, that will be no success. So our random variable can take value 0, no success, maybe first time success and another time no success. So 1 success also maybe, 2 success also maybe, 3 success also maybe 3 times getting success, maybe 2 times success, maybe 1 time success, maybe 0 times success. So random variable can take values like this, 0, 1, 2, 3. Now we have to make probability of this corresponding to, that means probability of x equals to 0. That means what? Probability of x equals to 0 means what? Probability of x equals to 0 means not getting any success. Similarly, probability of 1, probability of 2, probability of 3, getting 1 success, getting 2 success, getting 3 success, getting no success. Just we have to find and put here. Then we can find mean and variance for this variable. Mean means, generally, just I write now formula. I will discuss about it later. Okay. So formula mean. Mean what? Mean equals to sum of pi xi, and variance is equals to sum of pi xi square minus mu square. Mu means mean. These are the formula. Mu denoted by mu. Mu equals to mean summation pi xi probabilities variables x1, x2, x3, x4, and these are p1, p2, p3, p4. Summation pi xi will give mean. Variance summation pi xi square means this into this, here this into this, this into this, this into this, this into this, and sum of. Similarly, here first square it and multiply to it, and like this sum, we can get this minus mu square variance. That is our formula. Now our target is what? Finding this probability distribution for this random variable. So let us take x. So let x denotes the number of success. Then x can take values. X can take values 0, 1, 2, 3. Now we have to find this now. So this is for your hint. Now for finding probability, getting success means what? Now probability of success is equals to what? 1, 2, 3, 4, 5, 6 faces are there in a die. So on tossing one time, getting 1 or 6, that means there are 2 possible outcomes and total outcome 6. So probability of success is equals to 2 by 6 equals to 1 by 3. This is probability of success. So probability of failure is equals to what? 1 minus 1 by 3 equals to 2 by 3. Success 1 by 3. Failure 1 minus 1 by 3, 2 by 3. Clear? Now, maybe 0 success, 1 success, 2 success, 3 success. Now, we have Px equals to 0. That is probability of no success in 3 tosses. In 3 tosses, okay. TOS, no tosses. No success. That means what? No success. Failure 2 by 3. So 2 by 3 in first tossing. In 3 tossing, all are no success. Failure. That is no success. So this is equals to what? 8 by 27. So Px equals to 0, 27, 8 by 27. Similarly, Px equals to 1. Probability of 1 success and 2 failures. Probability of 1 success and 2 failures. Because 1 success and 2 are failure. probability of one success, two failures. So suppose in first tossing success and other two failures, 2 by 3 into 2 by 3 plus first failure, second success, third failure, and also first two failure, third success. That is three combinations there. That means 3C1. We can combine like this. Okay. This is equals to what? 3C1 combination, you know, 3C1 3. So 3 cancel, 2 4 by 9. This is 4 by 9. So Px equals to 1, 4 by 9. So this is one value, another value. Now Px equals to 2. That is similar probability of two success and one failure. One failure. Because to what? Two success means 1 by 3 into 1 by 3 into 2 by 3. One failure. This can be also 3C2. Because two success can be taken from 3 in this way. So multiply it. This is equals to what? Here 3C2 means also 3. 3 cancel, 2 by 9. So 2 by 9. This is value Px equals to 2. And another value for 3. Px equals to 3. Probability of all success. 1 by 3 into 1 by 3 into 1 by 3 equals to 1 by 27. Getting this value. Okay, 4 values are there. So now, corresponding to values of random variable, discrete random variable, we get probabilities. So now we can find mean and variance by using this distribution. Okay. So just write distribution and calculate the values. Okay. Thus we get the discrete probability distribution. Discrete probability distribution for x as x 0, 1, 2, 3 and Px corresponding to 0, what was 8 by 27, 8 by 27, 8 by 27 to 1, 4 by 9, 4 by 9 to 2, 2 by 9 corresponding to 3, 1 by 27. So this is discrete probability distribution of for random variable x. Okay. Now using this probability distribution, we can get mean variance. Clear? So mean and variance can be found. That is the formula. Now for mean, we know that mean equals to mu equals to sum of pi into xi. That is what? Here p1 x1 plus p2 x2 plus p3 x3 plus p4 x4. That is x1, x2, x3, x4. So mu equals to what? This into this 0 plus this into this 4 by 9 plus this into this 4 by 9 plus this into this 3 by 27 equals to what? This 3 by 3 999. So we can get what? Equals to 4 by 9 plus 4 by 9 plus 1 by 9 equals to 9 by 9 equals to 1. So mean is 1. Okay. So mean is 1. And variance. And also we can get, we require what? Summation pi xi square. Pi xi square. Xi square means squaring this and then multiply and sum. Okay, that is what? Pi 1 x1 square, p2 x2 square, p3 x3 square plus p4 x4 square. That is equals to what? p1 this into square of this 0 plus 1 square into this 4 by 9 plus 2 square into this 4 into 2 8 by 9 plus 3 square 9 into this 9 into this means 9 by 27. So this is equals to what? 4 by 9, 8 by 9, 9 by 27 means 3. Five by 3. I think 5 by 3. 5 by 3. This is 5 by 3. Value of this. Value of this. Okay. Pi xi square. 5 by 3. Therefore, variance is equals to what? Formula? Pi xi square minus mu square. Pi xi square minus mu square means 5 by 3 minus mu square means 1 square. 1 square. That is what? 2 by 3. So this is our answer. 2 by 3. This is variance equals to 2 by 3 and mean equals to 1. So what we do in this question? We have done what? Here, first of all, we have to identify what will be the random variable and what will be the values of random variable. And corresponding to this random variable, we find probabilities and listing them. Then this is discrete probability distribution for random variable. By using this random distribution, we can find mean for random variable. Mean formula is this, variance formula is this, and these are the calculation. Clear? So this is the solution for this question. Okay. Now, questions for your attendance. Okay. The first, there are simple questions, 3 questions only. Okay. So first question is, the probability density function of a random variable. The probability density function of a random variable is given like this: x equal to the value of x 0, 1, 2, 3, 4, 5, 6, and px also given. What? K, 3k, 5k, 7k, 9k, 11k, 13k. Okay. So very simple. This is discrete random variable cases. Okay. So find what? Px less than 4. Px less than 4. Here, what do you have to find? Px less than 4. Px greater than equal 5. And P x 3 less than x less than equal 5. 6. We have to find value of this. Very simple. Just as first question. Here given probabilities. Here all the value of random variables given. Corresponding probabilities are given in terms of k. In terms of k. So first of all, by using PDF, properties of PDF, probability density functions, we have to find value of k. How can we find value of k? By summing probability is equals to 1. By sum of this all the probability is equals to 1, we can get value of k. After getting value of k, we can find all the values. This is means what? Value of x are what? From 0 to 6. So x less than 4 means p x equals to 0, x equals to 1, x equals to 2, x equals to 3. You can get all the values, sum of corresponding values. You can get in terms of k. Put the value of k here. So you can get this. Also you can get this for x equals to 5. Greater than 5 and then 6. X equals to 6. You can get in terms of k, put the value of k. Get value. Here 3 less than x means px equals to 4 and then 5 and then 6 up to this 3 value. Sum of and then put the value of k. You can get the value. Clear? First of all, find these values. Now, finally, here one thing is more, that is what? What will be the minimum value of k so that px is less than equal to is greater than p less than equal to is greater than 0.3. Less than equal to is greater than 0.3. What will be the minimum value of k? So just you solve it. What? X less than equal to means x equals to 0, x equals to 1 plus x equals to 2. You can get value in terms of k and this is greater than 0.3. Now solve it. K is greater than what? That is minimum value. Okay. So you can solve it. So do it. Similarly, next question for your attendance. That is, a random variable x has the following probability distribution, just like same as previous question. Here, so x 0, 1, 2, 3, 4, 5 up to 6 up to 7, and probability is also given. Here k square is also involved. K square is also involved. So just do it as previous questions. First of all, sum of px equals to 1, get value of k, and then solve as previous questions. But here, what? Find the value of k and then probability of x between 0 and 5. Okay. So also x less than 6, x greater than equal 6, x less than 6, x greater than equal 6, and x 0 less than x less than 5. Okay, you can get all the value as previous questions. But here just see that for finding value of k, there will be quadratic equation, second degree equation. So you have to factorize and then find value of k, two value. Okay. If k is negative, then that value will be cancelled out, because probability density function, for probability density function, probability should be greater than equal to 0. So you take positive value. We take positive value of k, because there maybe two values are find. So one value may be negative. If negative, then that will be cancelled and positive value will take. Okay, and remaining part of set. Okay, so do it. There are two questions, and third question is, note down third question. Also, third question is here given. Third question is given. If fx equals to, here given fx equals to, just given fx equals to c by 1 plus x square, c by 1 plus x square, here minus infinitive less than x less than infinitive. Just like this given. Fx means PDF of continuous random variable. Continuous random variable. PDF of continuous random variable. Continuous random variable. Clear? So fx equals to, and find c and show that its corresponding distribution function is fx equals to what? 1 by pi tan inverse x plus half. Okay, so this is the question, given question. Okay, so here in given questions, this is given as what? Probability density function of continuous random variable. This here constant c. To find the value of c is also. So remember that if fx is PDF of continuous random variable x, then its property is what? Fs is greater than equal to 0. Fs is greater than equal to 0. This is positive and c must be positive value. So we have to find c. And another property is what? Minus infinity to infinity, fs dx equals to 1. In place of summation, here integration. So this is equals to what? 1. So by taking this condition, here minus infinity to infinity, so we can solve it. Clear? So integration of this in place of fx, minus infinity to plus infinity, c is outside, 1 by 1 plus x square dx. Here x square, that is even function. So minus a to a means what? 2 times of c, 0 to infinity, minus a to a, 2 times of 0 to a, 1 upon 1 plus x square dx. You can solve it. Tan inverse x, 0 to infinity, you can solve it. Clear? So after finding the value of this is equals to what? Will be 1. So you can get the value of c. After putting value of c, we get fx equals to 1 plus x square value of c. So we get PDF completely instead c, because in place of c just put the value of c. So this is PDF. Now we have to find distribution function. And you know distribution function is what? Distribution function is given fx equals to what? Integration of a to l. Distribution function is what? Fx equals to probability of x less than equal x. That is, this is equals to what? Minus infinity to x. Fx dx. Now just put the value this here. Minus infinity to x and value is there. Now integrate it. Now integrate it. Clear? So after integration you can get value like this. Okay? After integration you can get value like this. Okay? So these 3 questions are for your attendance. Do it. Okay? And send to me for your attendance.